Today's lesson will focus on dividing decimals by 100 and 1000. Okay, so we've been talking about the rules for when we multiply numbers by 10, 100, 1000. And in our last lesson, we looked at the rules for multiplying decimals by 10. Today we're really going to focus on multiplying decimals by 100 and 1000. So we're going to use what we've already learned and build on that with today's lesson. Now, as we continue to look at these rules, let's just remind ourselves about our place value system. Our place value system is called the base 10 system, and basically that's because in each place value, once you fill up to 10, it spills over into the next place value. So we have ones, tens, hundreds. Well, 100 is 10 times 10, and 1000 is 10 times 10 times 10. So each place value is 10 times the value of the place value before it. So I want you to keep this in mind as we are looking at the patterns of multiplying by 10, dividing by 10, multiplying and dividing by 100 and 1000. And see if you start noticing some patterns with the thousands being 10 times 10 times 10, right? 10 times 10 times 10 is 1,000. 10 times 10 is 100. We have the tens place and then the ones place. So keep that in mind as well. So let's start by looking at the whole number 3,000. So if we have 3,000 and we are going to divide 3,000 by 100, we're going to look to see how many hundreds are in 3,000. And so if we build using our place value chart, 3,000, we have 3 place value chips in the thousands place. Well, when we divide 3,000 by 100, there are 3 tens in each group. So there are 30 hundreds in 3,000. And so you can see that our 3,000s are regrouped into 3 tens because 3,000 divided by 100 is 30. And if you wanted to check that using the standard algorithm, we could do that. 3,000 divided by 100. Well, 100 goes into 300 3 times with 0 left over, and 0 divided into 100 equal groups gives us 0 in each group. And you can see indeed that our quotient is 30. And what happens when we divide 3,000 by 1,000? How many thousands are in 3,000? Well, we know that there are 3 thousands in 3,000. And you can see that when we divide, we have our place value chips. We have 3,000, 3 in the thousands place. When we divide 3,000 by 1,000, those place value chips regroup to 3 ones. And so 3,000 divided by 1,000 is 3. So let's look to see what patterns we're noticing now with the movement of the decimal point as we divide by 100 and divide by 1,000. So we know the decimal point is at the end of the number 3,000 because that is a whole number, 3,000. So when we divide 3,000 by 100, we can see that the decimal point moved 1, 2 places to give us 30, 2 places to the left. And when we divide by 1,000, if our decimal point is at the end of 3,000, the decimal point moves 1, 2, 3 places to the left to give us the whole number 3. So now let's look at some comparisons. You've probably noticed that when we divided by 100, look at how many place values we moved in the place value chart. How many places our place value chips moved? So we started in the thousands. We moved 1, 2 place values to the right to regroup to 3 tens. And when we divided 3,000 by 1,000, we moved 1, 2, 3 places to the right to the ones place. And if you look at the thousands is 10 times 10 times 10. And we moved 1, 2, 3. And 100 is 10 times 10. And we moved 1, 2. So you're probably starting to notice lots of patterns here between dividing by 100, dividing by 1,000, and the movement of the decimal point. Now let's look at the whole number 3. When we divide 3 by 100, think about where the decimal point is. Think about the place value when we're dividing by 100, okay? And think about what's going to happen to that decimal point as we divide 3 by 100. Okay, some of you are probably noticing that 100 is 10 times 10. Some of you might be noticing the 2 zeros in 100. And we know that 1, 2, that movement of that decimal is going to be 2 place values to the, we're going to move that decimal 2 place values to the left. And so as we regroup the 3 ones into dividing by 100, we're moving in our place value chart 1, 2 place values to the right to give us 3 hundredths. So 0.03 is 3 divided by 100. And what about if we divide 3 by 1,000? Well, we know that 1,000 is 10 times 10 times 10. So as we move that decimal point, let's move this down here. As we move that decimal point, 1, 2, 3, place values to the left, fill in with zeros. I'm going to have 3 thousandths, and you can see in our place value chart, here's our 3 ones. We will group 1, 2, 3 place values, 1, 2, 3 to the thousandths place. So we have 3 thousandths when we divide 3 by 1,000. Let's look at some more examples together. So if we had the number 235, that's 2 hundreds, 3 tens, and 5 ones. If we divide 235 by 100, remember 100 is 10 times 10. And so think about what that tells us about how many place values the decimal is going to be moving. Think about what that tells us about how many place values are that we'd be moving in our place value chart. So if I have let's start with the hundreds. If I have 2 hundreds and I divide it by 100, that's going to move our hundreds, or regroup our hundreds, 1, 2 places to the right in our place value chart to give us 2 ones. Then if I take my 3 tens, I'm going to move 2 places to the right, 1, 2, which gives us 3 tenths, and 5 ones would move 2 to the right, which gives us 5 hundredths. So it's going to be 2 and 35 hundredths. Now thinking of the decimal point movement in the number 235, when we divide by 10, we're going to be moving that decimal 2 places to the left. 10 times 10 is 100, so we're moving 2 place values to the left, 1, 2, plant our decimal point, and we get 2.35, or 2 and 35 hundredths. Let's look at another one. If we had 53 and 2 tenths, so we have 5 tens, 3 ones, and 2 tenths. And if I'm dividing by 100, remember 10 times 10 is 100. And so as I divide each place value by 100, I'm going to be regrouping into 2 place values to the right. So 5 would be 1, 2, oops, let's come back to that, 5 tenths, 3 hundredths, and 2 thousandths. So you can see 2 place values to the right. So 53 and 2/10 would be 532 thousandths when divided by 100. And if we look at our place value, or if we look at our decimal in 53.2, if we move it 2 places to the left, 1, 2, we end up with 0.532, just like we did in using our place value chart. Now let's look at dividing some numbers by 1,000. If we had 64 divided by 1,000, well, let's start by building 64 in our place value chart. We have 6 tens, 4 ones, and we know that when we divide each place value by 1,000, we're going to be moving 3 place values to the right in our place value chart, because 10 times 10 times 10 gives us 1,000. So the value of each digit in the number 64 is going to become 1/10 of its original value. So 1, 2, 3. Our 6 will move to the hundredths place. Our 4, 1, 2, 3, moves to the thousandths place. We have no tenths, so it would be 0.064. Let's look at our decimal in our number 64 now and see where the decimal is going to be moving in our number. Again, we're moving it 3 place values to the right. 1, 2, 3. 1, 2, 3. Plant our decimal point, fill in with zeros, and we get 0.064, or 64 thousandths, when dividing 64 by 1,000. And the last one on this chart, 4,061, if we build it in our place value chart, that's 4 thousands, 0 hundreds, 6 tens, and 1 1. We're going to divide by 1,000. So remember that when dividing by 1,000, each digit will be 1,000ths of its value. So if we look in the thousands place, we're going to be moving that in our place value 3 place values to the right. So 1, 2, 3. Same with the 0. 1, 2, 3. The 6, there's 1, 2, 3. And the 1. 1, 2, 3. So we'd have 4 and 61 thousandths. And if we come over and look at our number over here, we have our decimal at the end of the number because it's a whole number, 4,061. If we divide by 1,000, that decimal point is going to be moving 3 place values to the left. 1, 2, 3. So 4.061. So thinking about the patterns that we've noticed in the place value chart, thinking about the patterns that we've noticed in the movement of the decimal point when multiplying by 10, 100, or 1,000, and also thinking about what we know about our number system. It's the base 10 system. Let's see if you can divide these numbers by 100 or by 1,000. You can probably even do it mentally, but write it down if you need to. Move that decimal how you need to, and check back to see if your thinking matches mine in finding these quotients. Okay, so let's look at 235 divided by 100. My decimal point is after the 5, and so when I divide by 100, I know I'm going to be moving my decimal point 2 places to the right, or sorry, to the left. 1, 2, because 10 times 10 is 100, and so the quotient would be 2.35. And let's look at 53.2 divided by 100. Okay, here's my decimal point, and I'm dividing by 100. I know 100 is 10 times 10, so I'm going to be moving my decimal point to the left 2 places. 1, 2. And so 53.2 divided by 100 is 532 thousandths. 64 divided by 1,000. My decimal point is after the 4. And I know that 10 times 10 times 10 is 1,000. So I'm going to be moving my decimal point 3 places to the left. 1, 2, 3. Plant my decimal point, fill in with a 0. So my quotient would be 0.064. And on the last one, 4,061 divided by 1,000. I plant my decimal point at the end of the number, and dividing by 1,000, I know I'm going to move my decimal point 3 place values to the left. So 1, 2, 3. It is 4.061. Now that we've really practiced the rule for dividing by 100 and 1,000, let's look to see if you can study the quotient and the divisor to figure out what's happening with that decimal point. Where is it moving? How many place values is it moving, to help us figure out what our divisor would be. And I'm sorry, I said divisor over here. This is our dividend. So let's study the quotient. Let's study the dividend to see if we can figure out what will our divisor be. Will it be 100? Will it be 1,000? Will it be 10? Think about the movement of the decimal point and see if you can figure out what it would be. Okay, so you probably noticed that the decimal point starts after the 0, or the decimal point is after the 0. And in our quotient, it has moved between the 4 and the 2. So that has moved it 1, 2 places to the left. So that tells me that we are dividing by 1, 2, dividing by 100. So 420 divided by 100 gives us 4.2. Why don't you look at number 21 and see if you can figure out, are we dividing by 10, 100, or 1,000? Look at the movement of the decimal point and see if you can figure it out. Okay, so our dividend has the decimal point between the 0 and the 5, and in our quotient, the decimal point has moved to before the 0. So let's look to see at the movement of that decimal point from the dividend. So it moved 1, 2 place values to the left, which means I'm dividing by 1, 2, 100. Go ahead and look at number 22 and study number 23. Pause the video and see if you can figure out dividing by 10, 100, or 1,000. All right, so on number 22, in our dividend, our decimal point is right after the 1. And you can see in our quotient, the decimal point has moved between the 1 and the 0. So it's moved over to this place. So if we move that decimal point 1, 2, 3 to the left, that means that we're dividing by 1, 2, 3. We're dividing by 1,000. And if we look at number 23, the decimal point is after the 0, 890. And in our quotient, it is now before the 8, so it's going to be planted in front of the 8. So the movement of that decimal point would be 1, 2, 3, place values to the left. And so in our answer, it would be, 1, 2, 3, we're dividing by 1, 2, 3 by 1,000. Now we can use what we know about dividing numbers by 100 and 1,000, and we can divide decimals by multiples of 100 and 1,000. And we can use that same rule. So let's look at an example together. If we wanted to divide 28 by 200, 200 is a multiple of 100. And so all we need to do is break that down. So we can say 28 divided by 2, which is a basic fact for us, divided by 100. So 28 divided by 2 is 14. And 14 divided by 100, well, if the decimal point is after the 4 and we're dividing by 100, we know we're going to move the decimal point 1, 2 places to the left for a quotient of 14 hundredths. Let's look at 2.8 divided by 200. Again, 200 is a multiple of 100. We can break that down so that we have 2.8 divided by 2 and then divided by 100. So 2.8 divided by 2 would be 1.4. And 1.4 divided by 100, well, let's move that decimal point. So we have the decimal point between the 1 and the 4. And when we divide by 100, we move it 2 place values to the left. So 1, 2, fill in with our 0, and we get 0.014 or 14 thousandths. And finally, let's look at 69 divided by 3,000. Well, 3,000 is a multiple of 1,000, right? 3 times 1,000. So we can divide 69 divided by 3 and then divide by 1,000. Well, 69 divided by 3 is 23. And when I divide 23 by 1,000, if my decimal point is after the 3, then I know I'm going to move that decimal point 3 places, 1, 2, 3, to the left. 1, 2, 3. Fill in with a 0. So 69 divided by 3,000 is 23 thousandths. Let's look at another one where we are dividing by a multiple of 100. So we have 16 divided by 400, and we know that 400 is a multiple of 4 times 100 is 400, so 400 is a multiple of 100. So because we know that, we can do 16 divided by 4 divided by 100. This is a basic fact we should know, 16 divided by 4. And 16 divided by 4 is 4. And so 4 divided by 100, well, we know that when we divide by 100, the decimal point is going to move to the left twice, right? 10 times 10 is 100. Or you could look and see we have 2 zeros in 100. So we know we're going to move our decimal point to the left 1, 2, plant our decimal point, fill in the blank spot with 0. And so we have 4 hundredths. So 16 divided by 400 is 4 hundredths. I'm going to have you try these next 3 on your own. The first thing you're going to want to ask yourself is, what multiple of 100 or 10, 100, or 1,000 am I dividing by? And then think about the basic fact that you know in order to solve, and then divide by 10, 100, or 1,000. So for example, I know that 30 is a multiple of 10, 3 times 10, and so I can use a basic fact like 18 divided by 3, and then I can divide that by 10. So go ahead and look through these next 3 and then check back to see if your thinking matches. All right, so 18 divided by 3 is 6, and 6 divided by 10, well, my decimal point is after the 6, and since I'm dividing by 10, I know I'm going to move my decimal point 1 place value to the left. So this becomes 0.6. Let's look at this next one. 1.6 divided by 40. Well, I know 40 is a multiple of 10. 4 times 10 gives us 40. So I can use this to divide 1.6 divided by 4, and then divide that by 10. So 1.6 divided by 4 is 0.4. And 0.4 divided by 10, well, I would move my decimal point 1 place to the left, since I'm dividing by 10, fill in with 0, so it would be 0.04. Now, if you're wondering how I knew mentally that 1.6 divided by 4 was 0.4, Well, I know my basic facts, so I know 4 times 4 is 16. So I knew because it was 1.6, it would have to be 0.4. But if we divide using the regular algorithm, remember we line up our decimal point with the dividend. And so our decimal point is right up there in our quotient. And we know 4 goes into 16 4 times. And so with nothing left over. And so indeed 1.6 divided by 4 is 0.4. Let's look at this last one. We know that 60 is a multiple of 10 because 6 times 10 is 60. So we can use this and kind of break it down as a basic fact because we can do 24 divided by 6. We should know that. And then divide that all by 10. So 24 divided by 6 is 4. And 4 divided by 10, well, if I put my decimal point behind the 4, when I'm dividing by 10, I move it one place to the left. So this would be 0.4 or 4/10. So in this lesson, we looked at what happens when we divide decimals by 100 and 1000. We also looked at what happens when we divide decimals by multiples of 100 or thousands. So example, 28 divided by 200. 200 is a multiple of 100. 2 times 100 is 200. So we can use that to give us a basic fact, like 28 divided by 2 is 14, and then we can divide 14 by 100.